Hey, good morning, guys. Hope this video finds you guys well this morning. As you continue some type of routine, or maybe you're just jumping in for the first time. You guys know that I'm always really real with you, very transparent with you guys, and there's always going to be in these like quarantine and like self-isolation days, like there's some really good days and really bad days. Some days you're going to wake up be really excited, some days you're going to wake up happy, some days you're going to wake up really drained. Today's one of those days where I just feel anxious and frustrated and sad that we're not all together, but I'm going to power through. Hopefully this lesson challenges your brain a little bit, and I will see second and third period later on today. Speaking of second and third period, shout out to my boy Asher and his mom and his family. They helped me surprise Miss Jones for her birthday by making the best cookies I've ever had in my entire life. Told Asher I'd embarrass him by putting this picture of him on his porch. Definitely socially distanced. They were on their porch. I was in my car. But it was really good to see them. But shout out to y'all. Zoom call at 11 o'clock for second and third period. Third period, I texted it out last night to your family. Second period, I'd already texted you guys earlier in the day, so I didn't want to bombard you with a bunch of other texts. If you check your Everett's email, the link is on there for the Zoom call today. Okay, so here's your bell ringer. Go ahead and think through these questions. Please click pause in 5, 4, 3, 2, and pause now. All right, welcome back. So remember, when you have a data set, we've been working on this for a while, so this is a good little review. What is the first thing you need to do? Hopefully you put it in order from least to greatest, so I'm going to do that first. So it looks like our smallest is 45. Then our next biggest is 51. Then we have a 79. Then we have an 83. Then we have 93, 95, and then 99 and a 102, because you big ballin'. And that's your business. Alright, so that's from a TikTok in case y'all didn't remember that. Alright, so I'm going to do the mean last. We're going to do the median. So I'm going to put a check mark from each side till we get to the middle. And it's 93, so the median is 93. The mode is a number that occurs the most. There's no mode because no numbers are repeated. The range is 45 taken away from 102, which is 57. And if we wanted to on this data set, we could create a box and whisker plot, but that's not necessary for this question. So the mean, how do you find the mean? Remember, it means the average. So you have to add all of these data points together and divide by how many test scores there are, which is 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to add them together in my calculator. You should do the same, and then divide by 8. My sum was 647, and when I divided that by 8, I got 80.87 and 5 thousandths, and so that would round to your average would be 80 and 88 hundredths. Okay, using the distributive property. Remember, distributive property means to multiply. It's one of the biggest things I told Miss Larson we worked on, so make sure you really pull this together. So you distribute the 7 to the 2t, which is 14t, and then the 7 to the 8, which is 56. We're going to distribute the 4 to the p, which is 4p, the 4 to the 7, which is 28, the f to the 2f, which is 2f squared, plus f to the 5, which is 5f, 4 to the r, which is 4r, and 4 to the 3 is 4 times 3 is 12. Sorry guys, I'm struggling. 2 times 2 times 2 times 2 is 2 to the power of 4. It says exponential forms. Remember, you have a base and an exponent. 5 times 5 is 5 to the power of 2. And then 9 to the power of 5. List all of the factors. So we have 1 and 64, 2 and 32, 4 and 16, and then we have 8. Okay, then for 82, we have 1 and 82, 2 and 41, and that's literally it. 41 is prime and 2 is prime. So that was a dumb question. So the greatest common factor is 2. List 8 multiples. I'm going to say 5. 8 is too much. That was ambitious. 6, 9, 12, 15. And then 5, 10, 15. The LCM, least common multiple, is 53. Okay, so this is a dot plot. And what we're going to do is we're going to try to tie in the percentages that we learned into our dot plots as well. Okay, so look at this, click pause and take a second to analyze the dot plot. What is it telling you? What do the circles mean? What does the title of the graph mean? And so on. Okay, now that you've memorized it, sorry, long stutter, now that you've looked through it and analyzed it, what do you notice? You see that this is a graph that is hours spent on homework per week. So how much? So they surveyed a bunch of different students, and they wanted to see how many hours they spent on homework. Okay, so here's my first question for you. What does 0 mean in the context of the question? It means that one student spent 0 hours studying on homework that week. What does this 1 mean? Well, it means we got to count the dots. 1, 2, 3, 4, 5. It means that 5 different people spent 1 hour studying, and so on. This is 4 people, 3, 4, 2, 3, 2, and 1. So it's really important to remember to count how many people are total in the survey. Why is that important? Because what happens when we ask percentages? So we're tying in 2 different major standards into one. So let's count to see how many total people were surveyed. We have 1 plus 5, which is 6, plus 4 is 10, plus 7 is 17, plus 5 is 22, plus 3 is 25. So they give us a good round number. Okay? So what is the percentage? Remember, percentage means per 100 of people who spent 1 hour. So if you look at the 1 hour, there is 1, 2, 3, 4, 5 people. Over how many people were in the survey? 25. Oh, I hate teaching without an audience. Multiply by 4. Multiply by 4. Why did I put 100 right here? Because percent means per 100. You multiply by 4 to get to 100, so do the same thing. So 5 times 4 is 20. So 20% of the students spent 1 hour on homework each week. Well, what percentage of students reported spending 4 or fewer? Okay, so 4 or fewer. You need to know how to be able to analyze. So I'm going to use red. So 4 or fewer is this segment right here. Okay, so it includes the 4. If you want to use an inequality, it'd be x is less than or equal to 4. Look at that, combining multiple standards. All right, sorry, I impress myself sometimes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 students. So 17 out of 25 is equal to x over 100. Multiply by 4. Multiply by 4. I don't know what 17 times 4 is, so I'm going to use my calculator. No shame. And it is 68 over 100. Now, what does that 68 mean in the context? 68% of the students spent 4 or fewer hours on homework. So then it says, would 6 hours be a good description of the number of hours that the group spends on homework per week? Well, let's look at it. Only 3 out of 25 students. So 3 times 4 is 12. So that's saying only 12% of the students spent 6 hours per week. So just because it's in the middle of the graph does not mean it's a good. So the first answer would be no. Well, what about 1 hour per week? I mean, that's 20%, but is 20% a majority? No. So what would you say? I think 4 or fewer would be a better representation of what the majority of students did. Because majority just means more than half. Okay? This dot plot shows the weight of backpacks in kilograms of 50 sixth grade students. So key thing right here, save yourself time. There's 50 sixth grade students at a school in New Zealand. And it measured the weight of backpacks in kilograms. So the dot plot shows several dots at 0 kilograms. What could the value of 0 mean in this context? Take a second to think about it. The 0 context is really important for setting you up to 7th grade. So now that you've thought about it, hopefully you did not say, well, their backpacks just weighed 0 ounces or 0 kilograms. No, it means 3 students did not have a backpack. I guess technically they could have a backpack that weighed 0 kilograms, but realistically, no. 25 sixth grade students were asked to estimate how many hours a week they spend talking on the phone. This dot plot represents the reported number of hours of phone usage per week. Okay? So go ahead and take a second, analyze this graph. You see that there's a title, hours on the phone. Remember, one dot represents one student. Now let's look at the question. How many of the students reported not talking on the phone during the week? Explain how you know. Okay? So remember there's 25, so look at that in the context of the question so we don't have to count all of the dots. And let's look how many a 0 has. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many students reported not talking to the phone? 10 students. And how do we know? Because the title is hours on the phone per week, and this represents 0 hours. So there's 10 students at 0 hours. That's how you interpret it. So what percentage of the students reported not talking on the phone? So how many were there total? If you look at the top, it says 25. So out of 25 students, 10 out of 25% means per 100, multiply by 4, and 40% of the students did not talk on the phone, which is kind of true of you guys. You guys all text, DM each other on Instagram, Snapchat, and TikTok DMs, but a lot of you guys get really uncomfortable with talking on the phone, which is interesting to me. It actually kind of started with my generation. All right, couple more slides. Got to wrap this up soon. So it says 25 sixth graders were asked to estimate how many hours a week they spend. Oh, same question, sorry. Duh, same question. Now we just have some follow-up questions. What is the largest number of hours a student spent talking on the phone? Take a second to think about it. Now don't say 0. Don't get tripped up by this question. The largest number of hours. It didn't ask for what had the most amount of students. So the largest amount of hours was 3. If there was one point on 10, then the answer would be 10. Okay? What percentage of the students reported not talking on the phone? So we already answered that. So sorry, that's a repeat question. That was 10 out of 25, which was equal to 100 per 100. Because remember, percent is per 100. 40 over 100, which is equivalent to 40%. Also write that as a decimal, is 40 hundredths. What percentage of the group reported talking on the phone for this amount of time? That's a dumb question. So let's say, what percentage of the group reported talking on the phone? A couple ways you can do this. You can count all the points that are left over, which there should be 15, and do 15 over 25 is equal to 100. Multiply 15 times 4, and you get 60. Or you can use your common knowledge and know that it's 40%, and you do 100%, because you can never have over, that's not true. You typically will not have more than 100% when you're talking about a body of people, and so 100 minus 40 is 60%. Okay, this one's where you get a little bit more challenging. This is a teacher, so we can say Mr. Paxton. Shout out to Coach Paxton, Mr. Paxton. Him comparing the beginning of a course typing test to the end of course typing test. So if you look right here, this is the beginning, and then down here in blue is the end of the course. And you look at the number of words per minute. Okay? Based on the dot plots below or above, do you agree with this following statement about the groups of students? Be prepared to explain your reasoning. This is where, actual teaching, actual classroom discussion would be helpful in elevating your learning, but, it is what it is. Overall, the students' typing speed did not improve. They typed at the same speed at the end of the course as they did at the beginning. Can that be justified by this graph? Comparing these two graphs. I'm going to say no, because if you look in the beginning of the course, there were students, a lot of the students were in this bottom range of the spectrum. And then towards the end, there were no students in this bottom range of this in the projection. Now, what we don't know is individual data points. So what we don't know is this group right here. Did they improve? I mean, you could assume that they improved, but they could have also stayed right around the same typing speed. You're not sure. So the answer is disagree for that question. Okay, so here's the final thing. I don't have any place for you to upload it, so you can either text it to me, you can email it to me, you can show it to your parents, you can text it to your friends, or you can just do it and throw it in the trash, whatever is your fancy. Remember, my phone number is 770-855-2017. So I want you to create your own dot plot, and this is going to involve research skills. So using Google or whatever, I want you to use your research skills and create a dot plot. You can choose one of these three options. Option 1 is points scored by your favorite sports team in the last 10 games, length of your favorite 10 favorite movies. So you're going to do that in minutes. So you're going to have to convert from hours to minutes. Remember, there's 60 minutes in 1 hour. Okay, and then the ages of your 10 favorite celebrities. You can do one of those examples, you can do two of those examples, you can do all three of the examples. You can create your own question that you want to research. But this is to kind of tie into social studies and honestly just like being a good citizen, of being able to research topics in math. So this is like a pretty cool idea that I was pretty glad that I found. Second, third period, I'll talk to y'all soon. Love y'all. A lot of information is going to be coming your way over the next few days, so be ready to learn and to grow with us. It's going to be interesting. Care about y'all a lot. Bye.